Hello macroeconomics students. I wanted to offer a little bit of help with the Chapter 7 homework. This deals with the concept of inflation. As always, I strongly encourage you to read through the material in the text, watch the PowerPoint, and make sure that you're comfortable with the concepts before coming to this application and practice. Number one deals with the idea of currency, inflation, and really devaluation in Zimbabwe. And they ask you about the price of a loaf of bread in Zimbabwe measured in US dollars and in Zimbabwe dollars. And in the problem, they give you the information that you're going to need to calculate that. So they tell you that $33 would be enough to buy 6 loaves of bread. So this is going to be, for US dollars, we're going to go $33 divided by 6 to get the per loaf cost. And they tell you that that $33 US is the equivalent of 100 trillion Zim dollars. So to get the Zimbabwean cost of a loaf of bread, we'll take 100 trillion, divide that by 6, and that gives the per unit cost in Zim dollars. So that one's pretty manageable. The second one also just asks you to recognize the difference in the average inflation rate and the inflation rate for college tuition. So it says, by how much did the pace of tuition hikes exceed the 2016 average? Well, college tuition went up by 2.7. Average was 1.3. So if we do some subtraction, we'll get the difference there. Starts off pretty easy. The third one asks you to calculate the inflation rate. Inflation rate is the change in CPI value. That is something you should probably know from having read the text, having looked at the PowerPoint. If you're not comfortable with what a consumer price index is and how an index takes inflation out of it and allows you to calculate an inflation rate, then go back to the material first before you do the application. Otherwise, what you're going to do here won't help you understand the concept better. It'll just help you work through the math with very little understanding. So I strongly encourage that. But here, to do the inflation rate calculation, you're just going to calculate the rate of change from one CPI value to the next. So from 27 to 2008, for example, here's what we would do. And the rate of inflation calculation is a really simple one. We use it a lot. It's new minus old over old. And we multiply the result by 100 or move the decimal over 2 places to get the percent change or rate of change. So to calculate the inflation from 2007 to 2008, we would set it up like this. 215.3 minus 207. Let me get rid of that. 207. Let me go back to what I was doing. 207.3. All of that over, so that's new minus old, and over the old 207.3. That result will multiply by 100 and give us the rate of inflation. And then the last part here, part B, asks us to recognize that a positive change is inflation and a negative change is deflation. So that's really just definitions of it. Number 4 is asking us to calculate inflation. However, it's a steady rate of growth of the value of something. So we're going to use the future value formula that's given right here. And we're going to be getting the average, and we're told that if the rate of growth continues at 3.6%, what is it going to be in future years? So if we start with 2016, 2017, that information is given to us. So we know that that's 33,480. And then the next one, we're going to add that 3.6% growth. We're using our future value formula. So we're going to take our current value, our present value, 33,480, times 1 plus the rate of growth. In this case, it's 3.6%. That's given to us as the average. And the time period is here. And in this case, it's 1 year, from 1 year to the next. So it's going to be to the first power. So we do that calculation, and we get the future value of this in 2017, 2018. We're then going to take that value and put it into the same formula for the next calculation. Instead of being 33,480, it'll be whatever we got from this calculation here. We'll plug that back in. We'll multiply it by 1 plus 3.6 because they're assuming that it's the same rate of growth over this time period. And it's 1 year at a time, so it's always going to be to the first power. So once you understand that formula and plug the values in, you should have a pretty easy time of it. Number 6 uses a similar process, but instead of 1 year at a time, we're going to aggregate years. So we're going to use that formula with future value. Actually, we're going to reverse it. Instead of calculating future value, we're going to calculate present value. And you'll see how this is going to work. So it says, suppose you have an annual nominal income of $40,000 for each of the next 3 years. And the inflation rate is 5% per year. So you're given some information here. And we're going to use the present value formula. If you go back to the previous future value formula, we'll find that we're just rearranging the information. It's kind of like algebra. And so present value is equal to future value divided by 1 plus growth in prices to the power of the time period involved. And the present value of next year's income is next year's income. See, and we're just reversing that same formula. If we want to know present value, we take future value divided by 1 plus growth in prices. So we're going to go here and let's start with A and find the real value of your $40,000 salary for each of the next 3 years. So we're going to start with the present value because we want to know what we're dealing with right now. So present value is equal to the future value. We were just given that next year's income, right? Divided by 1 plus the growth in prices. So we have next year's income, $40,000. We're told that it's a nominal income. Divided by, we're using the formula right here, 1 plus the growth in prices. We're given that the inflation rate is 5%. And we're told that for year 1, it's for that period of time, so it's 1 year. So that's the real value of our $40,000 salary for year 1 is going to be this calculation. $40,000 divided by 1 plus 5%. So watch out for this because it's not 6, it's 1.05. Right? So 5% is 1.05. Does that make sense? So 1 plus 5%. You got to watch out for that. It's very tempting to look at that and go, oh, it's 6. It is not. It's 1.05. So we're going to divide, 40,000 by 1.05. And I'll go ahead and help you out with that. You're going to get $38,095. So that is the real value of my next year's salary because it's being eaten away by the fact that inflation is rising at 5%. So that's what we're calculating here. In year 2, now we're going to go to the second year. We're going to take that $40,000 again because we were told we were going to get that nominal. But in year 2, there are cumulative effects of inflation. It continues at 5%. So we're going to now divide it by 1 plus 0.05, 5%, to the second power. That's that compounding effect of the inflation. And so when we do this, and you can just run this to your calculator, hopefully you have a scientific calculator that will allow you to do that function, we're going to get 36,281. And I'm happy to help you with that much. I want you to go ahead and try year 3, and it's going to be a very similar process. 40,000, that's the nominal, divided by 1 plus 0.05, that quantity to the third power. And remember your order of operations. So you're going to do this part of the equation first and then divide 40,000 by that. And that's going to give you the value in year 3. Now, part B of this is a little bit of a trick question. It says if you have a COLA in your contract and the inflation rate is 5%, what's the real value of your salary each year? Well, if your COLA is a cost of living adjustment and adjusts for the 5% inflation, then the real value of your salary is 40,000 because the cost of living offsets the inflation cost. So for each of those years, you're going to have your 40,000 in salary. So that one's a little challenging, but if you just understand the formula you're working with, you can work through it. Number 7 is about borrowing $1,000 worth of principal and repaying it at the end of 2 years, along with interest of 5% per year. And then we say the annual inflation rate turns out to be 10%. So they ask, first of all, what's the real rate of interest on the loan? So the way to understand real, and here's a basic formula you can use. This is also an identity that can be rearranged like we did with future and present value. Real equals nominal, which is on its face, minus inflation. So we could say nominal equals real plus inflation. Okay? You can see how we could move those things around and have an equality that is the same statement. So in this case, we want to know the real rate of interest on the loan. And so we can say, well, the nominal inflation was 5% per year. And we have 10% inflation. So we're going to subtract 10% from that. So we have what we're paying on the loan, and we subtract inflation because that's the value of our money decreasing. So the real inflation rate on this is -5. So the real rate of interest on the loan is -5. This is one of those situations where a borrower benefits from inflation because they're repaying the loan with cheaper dollars, less valuable dollars, and so they actually come out ahead. So that's a benefit to the borrower in that case. The lender, of course, does not enjoy that. B says, what is the real value of the principal payment? And now we're going to use that future value calculation. So we're going to, here it is, future value is present value times 1 plus the growth in prices to the T, meaning the time period, where the number of years evaluated is T and all that good stuff. And so they give you the real value of the loan repayment. Another way to see this is the amount of the loan times 1 plus the real interest rate. So we're going to do the future value, and we're going to take the present value is $1,000, the nominal value. Another word for present is nominal. We're going to multiply that by 1 plus, now in this case we said our real interest rate is a -5%. Watch out for that, because remember it's not just 5, it's 5%, which is going to be 0.05. And in this case, it's a 2-year time period we're dealing with. So it's going to go like that. So here's what it's going to look like when we do the calculation. It's going to be 1,000 times, and 1 plus a -5%. Remember, we move that decimal over to turn that into a decimal number. And so this is going to be 0.95. It's 1 minus 0.05. That's how we would read that. And that quantity is squared. And if you remember your order of operations, you'll square this value, you'll multiply that by 1,000, and that will give you the value right here. So the future repayment is going to be less than the original loan amount because the economy is experiencing such high inflation that the borrower is repaying less powerful dollars. So the borrower actually benefits quite a lot from this. It's similar to the way people purchase homes and use them as hedges against inflation. Because when inflation is high, the value of the dollars that you're repaying on the original loan go down. And so it benefits the buyers. So in this last part, it says who loses, the debtor or the creditor? Definitely the creditor. The debtor who's repaying the loan is coming out ahead. All right. So let's go to number 9. Number 9 is similar to one you saw before, except now they're weighting the different parts of a basket of goods. And a basket of goods is how we calculate a consumer price index, where we gather all of the goods in a certain category and we put them together and we compare the value from one year to the next. So they've gathered them into some baskets here. And it says if apples, oranges, and bananas are weighted equally in a price fruit index, so take that out of this overall information, And it says, and no other fruit changed prices. By how much did fruit prices rise or fall in 2016? And we're really just going to take a net total of the changes in those three fruit prices. So we can say that apples, and we can find it here, went up by 6.8%. And the next one is oranges. I'm going to find it. Oranges went up 0.7%. And sorry, I keep losing what I'm looking for. And bananas went down by 1.0%. So if we just simply aggregate these values here, we'll take 6.8% increase plus a 0.7% increase minus a 1% increase, and we'll get our total value. So that one's kind of deceptively simple mathematically. It says, is the consumer, better or worse off if they love eating these fruits? And you can see it's going to be a net positive gain. So fruit prices rise, and so that makes the consumer worse off. Number 10 gives us a chance to calculate some expenditures and find the weight of each item in the basket. So the weight is calculated using a formula that is, I'm just going to show you the formula out here so as we're working it makes sense. We're going to take the annual expenditure on a particular category and we're going to divide it by the total expenditure. So we're weighting it within the category within the total, which is that ratio. We've seen that before in economics. Okay, so the annual expenditure part is really simple. It's quantity times price, and they give you that information. So if I buy 20 pounds a year, $7 a pound, my expenditure is $140 per year. If I want to know the weight of that $140 in the total, well, I need to know the total expenditures, which, you'll run through all these numbers, and I'll go ahead and give you the total just by way of explanation of this first one. And the total expenditure is $6,350. So when we do all these calculations, we get $6,350. So to get the weight of coffee out of the total, we just use this formula here. So we go 140 divided by 6,350. And it's going to give us the weight of coffee in the overall picture, and it is 0.022. So this one is pretty manageable once you understand how each calculation is done, and I don't think I'll have too much trouble with that. Let's see, number 11 is a little bit different. This asks for the percentage change. So they give us the price and quantity and the annual expenditure. So that's already been calculated for you. And your job is to calculate the percentage change in price. And that formula I gave you before for percentage change is given to you again here. New minus old over old times 100. So we'll calculate that for this formula, for this column, I should say. And then the average inflation impact is going to be basically the weight of the percent change on the price. So I'll show you what that looks like as we calculate it. So right here we can start a number. We'll just do a little bit of it. But for coffee, if the percentage change in price from last year to this year. So this one we can do the calculation new minus old over old. In this case, we can see it with our eyeballs without doing any math. So I'm going to be a little bit lazy here, and I'm going to say, well, it went from 140 to 280. So it doubled in price. So it had a 100% change. Now, if you're not comfortable with just seeing that, then run it through the new minus old, right? 280 minus 140 is 140 over 140. 140 divided by 140 is 1 times 100. So run it through that formula if you ever feel like you want to be sure. And that's not so hard to do. And then we're going to calculate this, we're going to take the weight, which is given to us, times that percent change. in price. So the weight from last year, and we're calculating the change in that weight, right? So 0.022 times that 100%, and we're going to get, for this one, 2.2%. So the math on that one's nice and easy because of the round numbers, but that's how you do it. So on the next one, we'll calculate the change in price. I have to get this right. Change in expenditure, excuse me. And so we have annual expenditure $4,000, and this year's expenditure $4,500. So we'll calculate the new value minus the old value divided by the old value, and that'll give us a percent change, and then we'll multiply that percent change times last year's weight. Okay, so watch out for that one, but try it and see how you do with it. And then they're going to have you get an average, and they give you, the total expenditures, and it's really easy to find this year's weight if you wanted to. I don't think they ask you to do that though, so that's not going to be an issue. But the average inflation then is going to be the total of this column. Okay, so to get this value, you're going to total this up. So I think you'll be okay with that. Let me throw in another number so you can check your work against it, because I know that sometimes you're going along and you think, well, am I doing this right? So let me just give you a value to help, and you can compare how you do with this one. So for example, let's go with pizza. The percent change in price from, I have to get this right, 1,500 to 1,800 is 20%. Okay, and the change, or the inflation impact, is 4.7%. Change in the CPI. So if you're in doubt and you're thinking, am I doing this right? Maybe that will help you, and you can kind of confirm that you're using the correct process. And if you get stuck on it, reach out to me and I'll do my best to be a little more clear. All right, number 12 asks you to simply calculate that impact on CPI, the inflation effect of certain price changes. And here, to calculate this, and they tell us how to do it, I believe, but here's what we're going to do. We're going to take the weight that's given to us here in this column, and we're going to multiply it by the percent change in price, like we did in the last one. And so it becomes pretty easy because you're given both those pieces of information, and you do some multiplication here. So for entertainment prices, we've got the weight of 0.51, the change in price of a positive 20%, so we're going to get 1.02. And again, I would encourage you to try it, make sure your math matches up or lines up with mine, and that way you can feel like you're doing it right and you're on the right path. Number 14, when Disney's Magic Kingdom in Orlando, Florida opened in 1971, the price of admission was $350. In 2017, the ticket price was $105. And so we're asked to calculate the change in the nominal price from 1971 to 2017. And we're going to do that in percentage form. Notice they want the percentage change. So we're going to use new minus old over old to do that one. Pretty easy. Times 100. And then it gives us a CPI index in 1971 and in 2017. And they want you to calculate the 1971 price in 2017 dollars. And in this case, here's how we're going to set it up. So I'm going to give you the formula, and you'll just use this. This is found in your book. It's a little bit tough to work through, but I'm going to set it up for you. So to find the real price, we're going to take the nominal price in 1971 divided by the price index. And the price index is composed of the price level in 1971 divided by the price level in 2017. So what we're left with is plugging numbers into this formula. So I'm going to walk through both of these just to try to be helpful, and then I'll show you how to calculate the real increase as well. So the first one, new minus old over old, I'm actually just going to help you with the setup. I'm not going to do it for you. But the new price in 2017 is 105, and so it's going to be 105 minus 350, that's the old price in 1971, divided by 350, and we'll multiply the result by 100. So for this, you shouldn't have too much trouble. For the calculation of the CPI index for Part B, here's what we're going to do. Well, we've got the nominal price in 1971, and that was 350, right? So we've got that. We're going to divide that by the price index, which is made up of the price level in 1971 and 2017. And we have those values right here. Right? 1971 was 40.5 and 2017. So we'll just set that up, and we'll do it like this. We'll go 40.5 divided by 245. Okay, so we're going to do that for the bottom value, and then we're going to divide 350 by the resulting value there. So it's a little tricky, but if you remember the original formula, we just plug in the values we've got. So we can do this one. Hopefully you can read my writing there. And then the last one, for the real increase, we're going to do this. And it's really new minus old over old, but let me just put it in terms that will help you see it in this problem. So we're going to take the ticket price in 2017 minus the real price that we just calculated in 1971 in 2017 dollars, right? And that's what we just did. We said we calculated for Part B the real 1971 price in 2017 dollars. Okay, so we're going to take the price in 2017, the ticket price, the nominal, minus this value that we just calculated. Then we're going to put all of that over this. You see it's new minus old over old, right? And so we're going to do that over the real 1971 in 2017 dollars. And multiply it by 100. So this is essentially the change, the percent change from 1971 to 2017. The price in 2017 minus the price in 71 calculated in 2017 dollars, which we call the real price, divided by the old price, which was the real 1971 price calculated in 2017 dollars. So I know that's a lot, and I know it's a little bit messy, but let me show you the setup just to kind of give you that final step here. And I'm going to come up here to the top because I've run out of room. And here's what we know. The price in 2017 is 105. And when we run through this number, let's call that value, well, actually, I'll just give it to you. I think I have it here. Yeah. So we get 2117. So we'll take away that calculated number, that 2117, all of that over 2117 times 100. All right. So I've helped you a little bit. I've shown you how to set it up, and then you can do the calculations for A and C. And my advice is, when I'm working in a limited space like this, it gets kind of messy. If it ever helps, maybe get a fresh, clean sheet of paper, organize your thoughts, write out everything very neatly, very cleanly, so that you can see what you're dealing with here. All right, on number 15, we're going to be going back to, let me fix that real quick. We're going to be going back to our understanding of that concept of real rates as the relationship between nominal and inflation, and they're affected by it. So let me start off by saying that real is what we defined it before as nominal minus inflation. And then we'll get started on the problem. Sorry about that little boo-boo there. It says, what happened in the period shown, the period here is 1991 to 2001, to the nominal price of gold. So here we're just going to read the chart, and we can say, well, The nominal price went down by 29%. That's given to us right there. So no problem with that first one. Then it says what happened to the real price of gold. Well, if we remember that real is the nominal minus the inflation rate, then we just plug in what we know. So we say, well, we're looking for the real. We know the nominal is negative 29 minus the inflation rate. And we said that the average price level is the inflation rate. So the average price level is 32%. So our inflation rate is a positive 32. So we're going to say minus 32%. So for gold, they experienced a negative 29. Overall, the average price level rose by 32%. So this is just simple addition in this point, or subtraction. But a negative minus a positive, or we could do it plus a minus 32. Either way, we sum these together, and we're going to get the real change in price for gold is equal to a negative 61%. Okay, so that one might have thrown you for a loop, but if you go back to that idea of real is nominal minus inflation, then you can see it there. 17 is a challenging question, asks you to put this stuff into a graphical context. You're going to use that graphing tool. You should do okay with it. So they give you the data below, and they ask you to graph the information. So you've got year on the horizontal axis at the bottom there, and then you've got GDP growth and inflation rate. So you'll just graph them as ordered pairs. So for example, 2006, the inflation rate was 3.2. And let's see, I guess they don't want us to do it for all the years. They said use the tools provided, blah, 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 blah. Oh, for the period 2012 to 2016. That's where I'm going wrong. Okay, so we'll start in 2012. The inflation rate is 2.1, and we'll just kind of estimate 2.1 to be about there, and so on and so forth. And we'll plot those 5 points from 2012 to 2016. So you'll get a curve in one case that goes approximately, let's see, I'm actually not even sure. So at 2013, it's 1.5. Let's see what it looks like. And 2014, it's 1.6. So it's be a little bit of an oscillation here. And 0.1. So 2015, it's going to take quite a significant drop. And 2016, 1.3. So it has some pretty major adjustments in there, so something like that. And then you'll graph the other information using the same graph, and you'll see that GDP growth varies in a different way. So then it asks you to answer some questions here. It says, in how many years was the official goal of price stability met? Well, if the official goal of price stability is to have inflation of less than 3%. So you have to remember that the goal is less than 3% is price stability and inflation. And by the way, I use the pi symbol for inflation. It's just kind of a lazy way of doing it. So how many years? And if we look from 26 to 2016, you can see what years were below that 3% threshold, and that's pretty easy. B said, in what year between 26 and 2016 was inflation the lowest? That's going to be really easy for you to just read from the chart, the inflation rate. And the highest, and again, you can just read that from the chart really easily. And then finally, C says economic growth and inflation rates tend to move in the same direction. Which appears to change direction first? And this you're going to take from your graph. And as you put in the GDP growth graphing information, you'll be able to see which one had the largest movement first. And I'll let you evaluate that. I don't think you'll have any trouble with it. And then the last one that I wanted to look at, and this was actually a little bit easier than I had first thought when I glanced at it the first time. It says, if home prices are expected to rise in the future, will you be more or less likely to buy a house now? So this goes back to the idea of future price expectations. If we expect the price of something to go up, what would happen to our demand today? So in this one, I want you to just consider that when you answer this. If we expect prices to go up, what do we do in the present day when it comes to demand for a home in this case? All right, so I'm going to let you work through that one. I don't think you'll have too much trouble with the homework. However, if you do, remember, try all the versions of the homework problems. You have 3 attempts. I would use them as a way to practice and to see this and to really implement these tools that we're using to understand how to measure inflation. And I wish you lots of luck.